Sure. Okay, so I guess we are already live.
Yes.
Okay. Okay, so shall we give the participants a few moments to gather up?
Yes.
So right now we have three.
I assume some of our audience are in the other channels.
Okay, so I don't know, should we wait any longer or maybe we can start? Because later this video will also be watchable on YouTube and I guess Facebook as well. So
Mhm.
anyone who wants to like watch it later will be able to do so, or catch up, let's say, with what has been delivered in the talk. So I think we will start. So hello, everyone. Welcome today in the series organized by IEEE Young Professionals R8. We have a talk delivered by Ahmet Köse. Dr. Ahmet Köse has received his PhD in 2020, and for IEEE has been active since 2008. And in Estonia specifically, he has um, been the chair of IEEE Estonia student branch for several years. And we have had the pleasure of working on several different interesting initiatives. So today, Ahmed, who is also involved with Taltech and RA technology, which is his primary activity now, will deliver a talk entitled Automated Fall Detection HVAC Systems with Machine Learning and Rule-Based Methods. So Ahmed, whenever you're ready, the floor is yours. Please go ahead.
Yeah, sure. All right. Hello, everybody. Before starting my talk, I would like to thank for this opportunity to Alexei, to IEEE Estonia section, as well as R8 young professionals. So once again, my name is Ahmet Köse. I'm the co-founder and then CIO of R8 Tech. So once again, Alexia mentioned that today I will be talking about automated fault detection HVAC systems, which is together with machine learning and rule-based methods. So before starting the actual topic, I would like to give a bit of introductions. The energy consumption is really important nowadays, especially related to CO2 emissions. Residential buildings, maybe 40%, they are related to energy consumption and CO2 emissions. And then the other part comes from the transportation and industry. And commercial buildings, maybe half of this consumption is coming from them. And then on the behalf of the R8, we are actually on the HVAC side, which is about the ventilation, cooling, and then heating, which is around 6% of the energy consumption. So from this dimension, we can formulate that R8 technology is in a software company which is working on HVAC systems in the commercial buildings. What kind of commercial buildings we would like to talk about? I would like to show a bit of the references, the buildings where we are. The names might not be familiar to you, but at least from the pictures or from the figures, you may able to see the most of the buildings are constructed recently or renovated, and they are rather large scale buildings. And there might be, some of them are the office buildings, hotels, the shopping malls, and so on. So actually there are lots of people, tenants, occupants, and then the operators are all working in the same facility or spending their hours for their purposes. And here, from this dimension, what I would say about R8 is that R8 is a software company. We are not doing any kind of hardware. We believe that such commercial buildings, especially which ones are constructed or renovated in the last years, they do have enough investment from the hardware side. Therefore, we mainly focus on the software. Typically, at least in the European region, even maybe in Asia and Africa, the Siemens, Niagara, Schneider, Fidelix, even Sauter, they are some of most common automation systems. And then what we are doing is that we are connecting to this kind of automation systems. Maybe I would say more commonly open protocol or backnet-based communication layers. We are connecting on them, and then we are collecting the information, and then we are again writing back I would say in every 15 minutes. So why we are doing is that there are main three KPIs for collecting information from the commercial buildings and writing them back. The first of all, being energy efficient. And the second thing, as important as energy efficiency, the comfortable indoor climate. And then the third, the KPI for us is the technical conditions or the life cycle. So maybe it would be relevant to mention that if it is possible to receive or gather the BIM models or the information from the design level or from the available resources, we are also able to use this information. So this is not directly maybe related to the talk, but here what is important to give the information or introduction to all of you is that while we are on the point of view for the fault detection and diagnostics. So here now I would like to start the topic, the actual topic actually, why the fault detection and diagnostics are important in the HVAC systems. You may consider that, yeah, maybe in old buildings, there is a lot of problems as like old mechanics, but it's not the case that especially in the commercial buildings, large scale area, we are basically seeing, monitoring, and then observing, recognizing on daily basis. There are like hundreds and thousands of different kind of faults and anomalies. But again, what could be the motivation about? The first and foremost is the health and then well-being. If the HVAC systems in commercial buildings are not working in order, then they will cause a lot of health-related problems. And then most likely the tenants and occupants will not like to come to the facilities, or they will keep complaining and they will have maybe more serious issues. Secondly, the green or sustainable building is really one of the most important, I would say, the segment or the item in this list. The reason for that, the efficiency really a lot matters for all the items below. And if there is no efficiency after all those kind of investments for the building, then it's not possible to talk about the green or sustainable building. Another kind of FTD is about task management. I will come this to the later on in details, but shortly what I would say is that there are possible to find maybe hundreds of the faults or issues within the same building. But at the same time, if we are providing or if we are generating lots of problems, somebody needs to order in, or somebody needs to put in order or put the priorities. What is most important, what is least important. And then in the practice, in the real life, it is not the case that the facility managers or the owners of the building will keep continuously invest to the tasks or the issues. Because typically what happens in the commercial buildings, every year they prepare their budget, and then the following year should be somewhat consistent with what was decided as a budget. So in this case, the important is that how many faults or how many tasks can be fit to the budget, and then can be basically used in the most efficient way. Another thing about related to the budget is maintenance cost. So if we do not understand what is the root cause of the problem, if we are able to give the right information or the right location of the problem, then the cost will not help, or the cost, what we are in terms of the time cost and in terms of the money cost will not be well paid, or the return on investment will not be as expected. The second thing about HVAC optimization. So this is like very simple. If the mechanics, the HVAC mechanics do not work properly, it is not possible to talk about optimization. The property value could be said that the more efficient, more green and sustainable facility will have naturally higher value as a property. And the life cycles, this is like maybe another important item to list, is that life cycle of the components, life cycle of the physical devices has direct correlation with the problem. So if there is some sort of oscillations, leakage, sensor failures, which is causing a lot of troubles for the components, the life cycle naturally will be shorter. And then for at least on behalf of the R8, this is really important for us as well, that enabling control adjustments. What does this mean? That if something is not possible to control, then we are not able to provide our service. So under those items, that's why we really pay attention on behalf of the R8 regards to the fault detection and diagnostics. So what is the current situation? Maybe some of you perhaps know about or aware of the current systems in the buildings, but still, like, it could be relevant to present and talk one more time about the building management systems. So building management systems, at least my understanding or my thoughts are that they are the user interface which is given for the technicians or the operators to interact with the HVAC systems, which is connected to a building automation system. So from this dimension, they do have a graphical interface, and then they do have icons, and they do have some sort of the sensor information, and then they do have some control set points meant for the human being to adjust. And then it is possible to do some trending, some observations, but they are more like a linear control graph, or some sort of like a linear logic is embedded on them. And they do have a abstract or straightforward alarms which is like once again to notify the operators or technicians who are responsible for the technical systems. And then depending on the brands or the benchmark, that they might have a different kind of slightly different design, but again, from the perspective of the functionality, they are under the same classification. So they are good. Yeah, I cannot say anything. They are really must to have in the commercial buildings, but then once again, they are meant for the operators, for the human being. So which means that there are thousands of parameters to observe and calibrate for the human being. So it is not possible to talk about any kind of optimization or thinking that one person would need to do lots of adjustments for building. It is really nearly impossible. And then from the FTD perspective, what I would say is that the BMS alarms, which comes from the BMS because of the simple condition checks, and the complaints come from tenants and occupants, or in a rare case, the coincidence. They are the main, sorry. They are the main resources for the fault detections in the commercial buildings without a rate. And then especially for the BMS alarms and the complaints, they are already too late to take care of it. So let's talk about the problem solving. In case of the BMS alarms and the complaints, this is like some sort of a result or conclusion from the problem. Especially from the complaints. If I say here in this building, there is some sort of a problem and I call a technician saying that I feel too cold. Okay, fine. And then what will be the operator will do? We'll go to BMS, we'll look at the potential adjustment. We'll try to increase or decrease the adjustment and wait. What comes next is that maybe the neighbors or the surroundings will start complaining again, or the issue will not solve, it will be remaining. Maybe we trying to solve the problem, what I'm saying or reporting will be causing greater problems in the same floor. So this is like some sort of like a long cycle, complaints, calls, etc. How much time consumed? We don't know. It really depends. If you are lucky, maybe you will solve in an hour. If not, it might take forever. We don't know this. But the second thing, if the actual problem is solved, if tomorrow, if again or not. So this is the important stuff, what we need to really to pay attention about the efficiency. The second thing, what we are saying is that the finding the root cause of the problem, finding the right approach, finding the actual problem is all about the efficiency. So the starting from the infrastructure or the architecture, I would say, in the BMS or in the traditional world, the heating, cooling, ventilation, and then the room controllers are independent or divided. So in other words, if there's some sort of a problem with the circuits from the heating and cooling perspective, there is no way that you can connect or interpret the information through the room controllers here. Or if the fan coils are not working in the rooms, or there is some leakage in the ventilation machines from the heating or cooling coils, then that doesn't really matter if you have a problem or not. From what you have as in a BMS, you will not be able to interact, or you will not be able to stop it easily. Maybe it might be possible to do some tricks, or to call the person who created the BMS for you, and then ask for further logics if possible, etc. But again, this will be a time-consuming and effort-consuming procedure to do. So this is the traditional world. What we do differently is that interconnect all the items available from in terms of HVAC, and instead of having isolated or independent classifications or groups, we interconnect them. So if there is a heating or cooling, and then the next layer is we call it relationship. It might be considered as a parent-child relationship, or it could be the functional relationship, but there is a direct correlation. So if there's a cooling and heating, then the ventilation and the room controller should be all connected to each other. And the reason for that, there is always supply and demand cycle. And then besides that, the building is dynamic, building is live. So which means that there are the weather predictions that if you know that after a couple of hours or after a few hours, there will be too hot or too cold, or like there will be some sort of impact to building, to the environment, it's not possible to find this information or use this information through the existing tools in traditional way or today in present without rate. And then there's also the market price, electricity price are keep changing in many countries to be more energy efficient, or the lower the cost, even though you are making the same consumption, could be possible if you are using this kind of service like a rate, etc. So from this point of view, it is really important to first is understanding what is the input and what is the output for the fault detection or for the entire operations on point of in the point of the digital operator. So how the digitalization work? Maybe we can a little bit touch on this information. Maybe some of you are aware again about the building commissioning, that but in general, how this works is in a couple of verses, that starting from the design, and then goes to construction, then it goes to the installation, then it goes to operations. Maybe 4 or 5 different stakeholders are in the process, and then typically they might have some sort of exchange the documentation in the paper or a digital format, but knowing then and making sure that the design was followed through the construction then follow what the installation, the automation, and then finally the operational matters are following up all the previous layers. It is nearly impossible again to validate this information. And therefore, there are lots of inefficiencies, or there are lots of problems are appearing. Maybe in design level, most of the things were thought through, but once come to real life, to practice, to operations, this is another scenario. So what we do is that, once again, I mentioned earlier, if there is information of the building information model, short BIM, is available, then we take the direct information to our layer. So what we do is that, looking at the capacity, looking at the parameters, looking at the limitations or the connections, it's possible to get all this information from there as how it was designed. So how does it help to us? We know already the models. We can already start doing the simulations, or another case, which is really relevant nowadays, the validation, to make sure that everything was designed and that everything was constructed and installed is the same way. So there are lots of opportunities here, and then having the digitalization is the main criteria, especially after the Industry 4.0. I would say that it became more realistic, it became more possible to apply, and that there is a great opportunity. And I know that there are lots of startups or SMEs are pushing this hard. So they are the maybe the abstract level of the information about the buildings, PMS, etc. But maybe we can start talking about the diagnostics and then fault detection in the more active way. So as I mentioned previously, is that the BMS alarms are there, and then some of them are really useful, and then they are giving very straight alarms, which is really the fire alarms or like high priority alarms, and then most of them are good. But again, the BMS do not have the feature of the data collecting, are data-driven decisions or data-driven the analysis. So if you know the possibilities, then it's possible like to make trending, and then you can download this in maybe CSV format or other kinds, and then you can make an offline analysis. But again, it's time and effort consuming stuff. There are reactive fault detections and then rule-based fault detection. There are a number of companies are able to connect and then read the information from automation. and then give some sort of a report, and maybe making the continuous or real-time monitoring. There are also a number of the companies are dealing with the on-site checks and making the measurements over in the facility, and then giving the information what to fix, etc. And then once we are going to a bit of down the pyramid, is that there are rule-based fault detection, what we are doing mostly, the learning-based fault detection, and finally the actionable insights with the statistics of building operations. This is like nearby the predictive maintenance. So every part, every layer has an additional value, but there are some things that everybody else can do, which is like already the most common things, and there are further the bottom layer of the pyramid, which is becoming more and more unique. And especially if you think about combinations of the building types, the automation systems, and then the combinations of the preferences. Let's say that in Nordics and Baltics, because of the weather or because of the cultural perspective, that there are different kinds of operations moving, but the same case could be totally different in the Southern Europe or elsewhere. So having all those kind of combinations adding together, it is becoming a real challenge in the business or in the professional world to provide really useful and then affordable information to the clients or the responsible people. So how we do, or what is the fact that we make different than others, or we try to do at least. So the first thing is about the fault detection. Yes, there are a number of methodologies. There are lots of scientific papers and the commercialized applications or the software available in the market. And then what we do is that we try to address those faults with the two main impact factors: energy efficiency and then indoor climate. So they are the main triggers for the human to understand why they have to go on site and fix it, or why they have to give this order to fix this fault at first place. So this is really what they appreciate on that, because otherwise, if we generate big list or large list of the faults, if this is like a really big chunk of it, and then in the end of the day, they don't have a motivation to do it, or they will consider it a long-term plan, or it will take too much time, but actually they don't know which is like the most important or least. By the know-how case, it's possible, but if I say that one sensor is unreliable or the sensor is broken, some of us maybe can consider that this is just sensor, what can happen? But if the sensor is like triggering the alarms, if the sensor is causing lots of waste of energy consumption or causing discomfort a lot for the indoor climate, then this sensor means a lot actually. So that's what we do in the practical world, that saying that why, if there are 20 sensors are broken, giving them the information what needs to be changed at first place, and then the ones that which is least problematic for the operation manager. So we talk about now the energy efficiency and indoor climate. I think energy efficiency is everybody has a good understanding that if the mechanicals do not work, then this is a waste of energy, etc. I will come back to it a bit later again, but it's rather straightforward. But people talk a lot about indoor climate, thermal comfort, well-being. So simple question, what is the perfect building indoor climate? According to who or according to what? Especially in commercial buildings, in some areas, in some buildings, the occupants decide what is the indoor climate preferences. In some areas, in some buildings, the facility manager has who is the decision maker. Especially in the portfolio companies or the portfolio level management, they have their own standards or preferences. They say that doesn't matter, is in Estonia or in the Finland or Norway or Europe, whatever, or Africa, that they want to follow up certain items. Or there are also another kind of group is that they want to follow the international or the national standards. It might be the H3, it might be the S1, S2, it might be ISO or kind. So 1, 2, 3, 4, maybe 5 different combinations. But again, what is the perfect building indoor climate? It really varies. But for behalf of the rate, this is not the actual question to us. We are saying that please let us know what is your preference. We are able to follow it, or we are able to let you know how far you are from your preferences. So from this dimension, data aggregation is the key to assess faults for us. In this picture, in the illustration, what we see is that there are the samples from the X building presenting every 15 minutes of the reading of the temperature sensors, for example, in the entire building. I would say maybe this is somewhere in winter or maybe November. And then this information, it just shows that based on the preference of the building, I don't know by heart what was their preferences, but doesn't matter again. Here we see that 60% of the areas in during out this defined period of the time, they were all good. And then the 22% is in the okay level. But there are 20% of the times or the areas we are in problem. So if we observe in the indoor climate around 18 or even like below 20 or above 23, 24, I assume that there has to be something wrong. So then that's already okay. If we are in this picture, if we understand what the figure says, the next question comes naturally. What is wrong? Here we are already start taking the attention or taking the interest of the person or the facility manager to see, investigate into actual problems. If we are making a bit of further integration or aggregation of the information, let's say that we aggregate the information one more time, or we are using another kind of illustration, and we want to be more concrete with these areas and points. So as is obvious, there are certain points on the bottom and then on the top problems happening. Traffic lights are maybe the most common or most universal way to give this impact or the understanding to the human being, where can be possibly wrong, or what is the distribution of the problems or the level of the discomfort. So again, if we have this kind of understanding, if you are able to collect the data from the building, if you are able to make the data analysis or data aggregation, we are able to already talk with the facility manager in the most attractive way. So why, again, why this is happening in my building? They are already giving us a very good header. And then what we do is that from the fault detection is that using this information in terms of indoor climate, saying that why the X in the X area or in the first floor, why the room temperature is too high, just because of that the fan coils, for example, didn't work, or they had some sort of anomaly. They are showing it's working, but again, your temperature is too high. We don't know this. So somebody should go and check, but there is a result, there is a certain problem. We can compare the temperature information, we can compare what is impacting the indoor climate. They're all available information, and then giving them a potential problem area or the default area to address, and then go and make site visit. The second thing, that actually everything is working. There is no mechanical failure, but there might be operational issues. If we are using very small dead zone or threshold for following up the target set point, you'll be able to see continuous heating and cooling. Heating and cooling comes from either radiators, the fan coils, or active panels, or other VIV systems, other whatever is available in the building. But they are, in the end of the day, they are heating and cooling and ventilation items. So if we have very small dead zone, then it will cause lots of heating and cooling cycles, which will consume more electricity or more heating than in the expected or in design level. And then other information, everything is again mechanically working, but because of some sort of a leakage, there will be lots of problems. And this leakage also may cause, as an example, we are following up with the supplied air temperature. It never achieves, and everything actually should be looking fine. You cannot see from the BMS, but the actual problem is that there is a leakage in the valve, and then it never reaches the set points. And there are lots of this kind of information, the aggregating, finding the information from the indoor climate and saying like what are the potential causes is helping a lot for us to address the issues. And then by doing that, we are maybe 10 times more precise. And then it's possible to save a lot of energy besides the maintenance cost and then increasing the efficiency as well. So what I would say is that now let's talk about more precise the visualization. Now we had this previously, the large scale picture. We were looking at the entire the building view. And now if you look at this problematic areas, what was the case over there? So maybe I would present this the case here, showing that what the figure describes or trying to do it is that the bars presents how far the building, how far the room has been out of the expected preferences, and then the bottom lines showing that what kind of area is that. It might be hotel, it might be office, or it might be just like a random numbers, but doesn't matter. The person who is responsible for the facility is aware of those numbers, or at least somebody should be. And then it just shows that in a couple of rooms, the discomfort rate was over 50%. There is a kind of range from 20, and then it goes on and so on. So in the high discomfort rate, it was more about the rooms were cold, and then what we see on the right side is that there are a couple of rooms were actually hot. And then the other axis on the right side presents that what has been the average temperature in the occupancy hours. It might be from 9 to 5, it might be 7:24. Again, it doesn't really matter. They are just reference points for us to aggregate the information. And moving from here, and then thinking through a bit of the faults, what I was giving some examples only. We have like, I would say hundreds of this kind of rules are inserted and they are working in automated way. So clearly, what has happened on the left side, the fan coil is highly likely been working continuously, unnecessarily, and then maybe either the target set point was too low, or they were forced to do some working mode or some other reason. But this reason, I cannot tell why, but I cannot tell what is the conclusion and where the problem is. And the second thing is about, if you look at the red colors or icons, that they are clearly saying that the rooms were hot. Again, it might be reason of the ventilation machines, it might be reason of the radiators, it might be a reason of the high occupancy, but all the information or the possibilities are can be given. And then I would like to take your attention in the middle, right in the middle, when we are looking at the information that this is in the 22.5, and then looks like another cold or hot. What has happened there? So it just, to my understanding, it just indicates that there is a lot of oscillations happening, going up and down. This is the average temperature. But when we are looking at the full or the let's say big data and looking at entire time of the period, high likely there has been the times cold and hot, just because of this maybe the threshold, or maybe because of other reasons, or at the same time the ventilation machines and radiators, they were all working together, and then they were just passing the inertia to each other. And then maybe the right side, it has been that sudden drift has happened. Maybe the radiators are working, and then the ventilation machines start working again, and it was very low temperature, something has happened. But again, the information, the picture is in front of eye, and now you can easily, clearly, and confident level, you can just say loudly what's going on in the building and then report this information. Why we are doing it, I explained previously, but the idea in the unified level is that minimizing the cost and the complaints at the same time. So if we are not using R8 or R8 kind of the service, or the software that is able to collect the information, make the necessary data analysis, and then providing the right and accurate information, we will never be there. Either it will be high complaint level, or it will be high cost level. If we are lucky, maybe we can, or if you are very well maintained or educated person, then you may reduce it. But again, the buildings are dynamic. The weather keep changing. In most of the countries, there are 4 seasons. And this is really impossible or very difficult to follow up with all this information. So this is like the ultimate goal. And then this is possible. This is feasible to become there. I would say that in the 2030, there's the carbon neutral goals and the CO2 emissions, everything is there. And then there is a renewable sources and the other alternatives are on the play. But in my point of view, saving the energy is the greenest energy. So if we are able to reduce the inefficiencies, reduce unnecessary cooling or heating, then we are going to save a lot, and then it will be most greenest way maybe. So how the data operation could work and should work, and then how R8 is doing. Once again, we are giving out this actionable insights, and we are giving this information in terms of the operational efficiencies and the mechanical failures to facility managers, and the facility managers distribute the information in the list level, or it might be another kind of format, to the responsible people. And then they're also providing information, what could be the preferences, either through occupants or tenants, or directly from their own responsibility, or if there's a building owner or other stakeholder, they give the information, and the information is forwarded to R8. And then based on their expectations or requests, we are making this intelligent control, which is a lot to do with the data-driven decisions and control, and just providing them information how well we are doing in the real time. So the fault detection and diagnostics, as important as it is, but the story doesn't end here. The flow of the information is really important. As I mentioned several times, that there is a BMS, which is really a must-to-have item, but it is abstract level at the moment. And then the technical operations receive alarms over there, receives emails or messages, and then this remains in their hands. In the BMS, there are lots of faults actually are missed, and technical operation level people, they receive some mails, some of them are just click acknowledged and then leave it over there. And then they are filtering out, or they just forget some sort of false alarms staying in their mind or in their email box, doesn't move to next level, technical lead. And then the technical manager again makes another filtering, or forget again, doesn't have time to give this information to the facility manager, goes all the way to the building owner or portfolio manager. In the end of the day, they don't have information about real information, transparent information what they are building. Here, there is nobody to blame, or there is nothing to be offended, but the real life is as it is. Having the information in the only one location, and this information is not able to move on in a simple way, in the understandable way, that they won't get the real point. And then because of that, probably they will not have enough budget, or they will not have a motivation or resources to go and fix the problems. And then this is the closed loop. If there is no transparency, it will be continue, or it will move on the same way for maybe years. So this is the technical part, but again, the R8 is in a R8 is in a company, and then what we are talking about here is about the business model, that we are making the saving-based business model, and therefore it helps us also that if we are providing a more transparent information flow for control and for diagnostics, we are able to present the more savings because that they have motivation to fix, and they have motivation to cooperate and collaborate with us. Maybe in the last few minutes, I'll just quickly talk about one good example. Just I want to take this example here. The main reason is that when I'm looking at this picture of the building, it looks quite new, and then looks like in a premium level. And then this is correct. This is like 2018 constructed year, 25,000 meters square office, and which has nearly 50,000 data points and 3,000 HVAC components. And the building has all the digital format information available. So what has happened with R8? In the 5 months, we were able to increase the thermal comfort from 6 to 90%. I will not go details right now, just it has happened exactly the way how I was explaining it previously, that the preferences, based on preferences, moving on from this dimension, going to the time, month by month, going to the upper and upper, because of the learning curve and everything. And then meanwhile, we also detect more than 900 faults and anomalies. And meanwhile, we naturally help to save quite big amount of the CO2. At the same time, the energy savings, there is no joke here, but this is the total consumption is over 30% of the savings, just doing all those information, like finding the problems and then making this intelligent control. And this has happened in this kind of commercial prime newly constructed building. So once again, in all buildings, we may consider that there are problems, but in new buildings, again, there are problems. So this is actually where we might able to see more deeper or more complicated problems, because the systems, the hardware and software, everything is getting more advanced, but still we are human. And we need to know, or we need like support tools to understand what is the critical issues, and then how to avoid and relieve them. Yeah, we are being noticed in the number of areas in the UK, in Sweden. I think the other one is also from the UK as well. And then this is like we are passionate to do this work, and then we are doing it every day with high motivation with me and my colleagues and then the team members. They are all working for the same purpose, that how we can make every day better and better. I would like to thank for your attention. That's pretty much it. I didn't want to go too much technical details, at least in this session. The main reason is that we have lots of available papers, articles, and the white papers, technical reports talk about lots of faults, but the important thing is that as important as the content, the way how we are able to deliver the problems to the right people. So thank you.
Thank you very much, Ahmed. Very exciting stuff. So, first of all, I would like to ask the attending audience, are there any questions? And we are streaming live in YouTube and Facebook, and also here on Zoom. we have this session. So if you want, you can use any channel to communicate your question to us. But just to get started with Q&A, I have a couple of questions. So if some other participants want to ask, then
Mhm.
please ask. But meanwhile, let's discuss some of these questions. So the first one is, of course, uh, as we all know, we've had this coronavirus pandemic event. And
Correct.
do I understand correctly that R8 Tech is focusing more on business clients? So on office buildings and not so much on the consumer market?
Let's put it this way: we don't focus on residential. We focus more about commercial buildings.
Yes, commercial buildings. Okay. So in that sense, how did this concept of home office affect the developments in R8?
Uh, in the beginning last year, it was chaotic because nobody knew before what could happen, right? And then everybody was locked down, and then all the commercial buildings were locked down. The business also impacted in a negative way. But then the last summer, people were back to the at least partially, and now even nowadays, I would say that even our rate is like a half of our team members are working home office, and then this is like a natural in this new normal. But the point of commercial buildings and business, they are still on, they are still working, they are still open, and then it's even like for giving us a kind of opportunities where we can reduce the cost if we know that if the what floors, what areas, what stores are closed, and secondly, making this stress test, handover test to say that what are the actual problems and without disturbing the discomfort or without disturbing the indoor climate meanwhile. So from this dimension, we take this kind of, we try to take this kind of events or the period of the hard times and an advantage. But yeah, this is the current situation. We hope that this kind of pandemic will never, hopefully it will not appear in the close future.
Okay, thank you. All right. And I have another question.
What?
So the next question I have is related to actually your doctoral thesis,
Mm-hmm.
as your main topic of development in the doctoral thesis was virtual reality or
Right.
extended reality, to be more general. So, and you also spoke about issues stemming from kind of using BMI systems by operators and uh, uh, so in that sense, do you see any like application of extended reality to these problems? And if so, how do you see them?
Uh, from the operation perspective, I would say that the one thing is about educating the technicians and operators to say that the how to use or how to present their adjustments, what they are trying to do. Because from the practical level, operators and technicians, they are some of them are in the same facility for years, but some of them are keep changing. And then the newcomers, they don't have a good understanding how the building, the inertia and building dynamics could work. And they are again making this kind of test and try, and then like what they hear from the previous operators. So this kind of package through the BIM or through kind of ready available in AutoCAD level to just show them what are the bottlenecks, what are the limitations, how to the how to behave in the when the server room or telecommunication room needs attention, and then this kind of information could be easily be presented, and then maybe give them illustration. Otherwise, educating or giving this kind of class lectures for the operators and technicians about the building dynamics is nearly impossible in real life. And then what I see is the virtual reality or immersive environment could be very remarkable in this patent, in this content.
Right. So it's like about knowledge transfer also, right?
Indeed.
Okay. Right. So we have a question from Dr. Alfaili. So the question reads: Is this system uh, can the system be installed on already installed air conditioning units?
Is the system is installed?
The system, I guess the question is about the software that you develop.
Yeah.
If we already have an existing system, how can it be applied to that system?
Well, the what I mentioned in the beginning of the talk is that we are a software company, so we don't do any hardware, and that all the hardware is available on site. So the references, for example, was just the one case to present. They're all commercial buildings, which they all have all necessary equipment and hardware and automation system available. Where we come into play, or where we are existing or operating, is that instead of pushing the human being operators to do adjustments in the BMS, we are doing it automated way. So we are collecting the building information, making necessary supervised learning, necessary modeling through the data, and then finding the most optimal value for the available set point, and then placing it in automated way. So from this dimension, we are actually the one that who are looking for existing systems. I hope it answered the question.
Hopefully, yes. Okay. So, um, thank you, Ahmed, for
Mhm.
answering the questions so far. Let's see if we have any others on social uh, streaming. So on Facebook, I cannot see any questions. On YouTube, I cannot see any questions. And here, I also do not see any questions.
Okay.
So yeah, I think at this point we can conclude. But if you have further questions, anyone who is listening to this and recording, if you have any questions to Dr. Köse about this topic, please make use of the email which you actually see right now on the screen, and contact him with your questions, business proposals, or
Yeah,
anything
I'm
else.
looking forward. Of course, from it can be from scientific level, it can be from the practical or technical level. I have interest for both dimensions. So yeah, looking forward any kind of questions, and then we can have also the chat or the some calls. No problem with that.
Absolutely. So, Ahmed, thank you so much for taking your
You're
time
welcome.
to deliver this talk. And at this point, I think we will conclude this session. Also,
Mhm.
thank you to all the participants and everyone who's watching this in recorded format. And see you soon during other events.
Mhm.
Bye.